Hey everyone, and welcome. If you're coming from the world of SQL, you already know how to group, sort, and join data like a pro. Today, we're going to connect what you already know directly to the massive distributed world of Apache Spark. Okay, let's jump right in.
So here's our game plan for this explainer. We'll start with why we even need this special data structure, then we'll walk through how to create it, how to do some powerful aggregations and transformations, and finally, how to join massive data sets together. By the time we're done, you'll see exactly how your SQL skills translate to Spark.
So, let's kick things off with a fundamental question. You see, in a normal database, all your data lives in one cozy spot. But in a distributed system, well, that's not the case at all, and that creates a really interesting problem.
And that is exactly the right question to be asking. You're probably thinking, hey, I'm a wizard with group by and join. Why do I need this extra step? Well, the answer is all about how distributed systems work. Your data isn't on one computer. It's split up or partitioned across maybe hundreds of them. So for Spark to do something like a group by, it needs a way to figure out which pieces of data from all those different machines actually belong together. It needs a guide, a common identifier. It needs a key.
And that brings us to Spark's brilliant solution, the pair RDD. This is the fundamental building block that gives us all this power. Just think of it like a special kind of list where every single item is a little two-part package, a key and a value. By structuring our data this way, we're basically handing Spark a map that it can use to efficiently shuffle, group, and join data across the entire cluster. This key/value structure is what makes things like a distributed group by or join even possible.
All right, so we get it. We need them. The next logical question is, how do we actually make one of these things? How do we take a totally normal collection of data and get it into this special key-value format?
The good news is it's actually super simple. You start with any standard RDD, maybe a bunch of log lines you just loaded. Then you just apply a map transformation. And inside that map, for every single line or element, you just tell Spark what the key is and what the value is. You know, the classic hello world of big data is word count, and it's a perfect example here. You take an RDD of words, and you map each word, like error, into a key-value pair, error, 1. The word itself is the key, and the number 1 is the value we're going to add up later. It's really as simple as that.
Now we get to the really fun part. We've got our data perfectly structured in these key/value pairs. So how do we actually do those powerful aggregations we know and love from SQL, like summing up all the values for each key? So Spark gives us two main ways to do this. But listen up, because there's a huge performance difference. First, you've got reducebykey, and this is the one you'll want to use 99% of the time. It's smart. It does a mini aggregation on each machine before it sends anything over the network. So for our word count, it adds up all the ones for error on each machine first, and then it shuffles just that one subtotal. On the other hand, groupbykey just shuffles everything. It sends every single one for error from all the machines to one single destination, which then has to hold all of it in memory to do the sum. You can see how that could easily cause network jams and memory errors, right? So, rule of thumb, always go for reducebykey if you can.
And boom, there it is, the direct connection. That super efficient reducebykey operation is the exact equivalent of what you've been doing in SQL for years. Writing select key, sum value, from table, group by key is conceptually the exact same thing as calling .reducebykey with a little function that just adds two numbers. It's the same logic, just with syntax for distributed world.
Now, for you power users out there, if you need to do something more complex, like calculating an average where you have to track both a sum and a count, there's combinebykey. Think of it as the powerhouse engine that reducebykey is built on top of. It gives you total control over the whole process. It's a bit more involved, but it's there when you need that absolute flexibility.
Okay, so we've nailed aggregations. But what about the other stuff we do all the time? You know, what if I just want to tweak the values but leave the keys alone? Or what if I need to sort my entire data set?
For transforming values, Spark has this really clever optimization called mapvalues. Let's say you want to square every value in your RDD. You could use a regular map, but Spark would assume you might have changed the key, and it might get ready for a big, unnecessary data shuffle. But with map values, you're promising Spark, hey, I'm only touching the value. That lets Spark completely skip the shuffle because it knows the keys and the way the data is partitioned hasn't changed. It's a simple change that gives you a great performance boost.
And what about sorting? Yep, you guessed it, another perfect one-to-one mapping from your SQL brain. That order by clause you've typed a million times to sort your tables? In the world of pair RDDs, that's simply sort by key.
It does exactly what it says on the tin. It sorts your entire distributed dataset based on the key.
So far, we've been working on one dataset at a time. But what happens when we need to combine two of them? That brings us to our final big-ticket item, joins. And you'll be happy to know they work just like you'd hope.
Once again, your SQL knowledge translates perfectly. An inner join in SQL, where you combine rows from two tables on a matching key, is simply RDA.join RDB. Spark takes care of all the messy business of finding those matching keys across all the different machines and putting their values together for you. And of course, just like in SQL, you've also got left outer join and right outer join for those times you need to keep records that don't have a match.
Whew, we've covered a lot of ground, basically translating a whole bunch of core database ideas into their distributed Spark versions. So let's do a quick flyby of the essential operations you're going to be using all the time.
Okay, let's lock this in. The big five you need to remember are reducebykey for doing aggregations the fast, efficient way. Groupbykey, which you'll use very, very carefully. Mapvalues is your best friend for changing values without causing a shuffle. Sortbykey is your order by, and join is your go-to for bringing two datasets together. Honestly, these 5 transformations are the backbone of pretty much all key-value data processing in Spark.
See, what we've just unlocked here is massive. It's the ability to take all those complex analytical skills you already have from the database world and apply them to terabytes, even petabytes of data. So I'll leave you with this question. What huge data problems, the ones that used to seem totally out of reach, can you go out and solve now?
And that's a wrap. I really hope this explainer helped you connect the dots between your SQL expertise and the incredible power of Spark. If you found it useful, do me a favor and hit that like button, share it with a friend, and subscribe for more deep dives. Thanks for watching.